In this video, we'll be talking about the conversion of current into voltage. So we have a circuit by virtue of which we can convert current into the voltage. So the input current uh, uh, is directly proportional, or I should say, the output voltage. Say VO is output voltage, and input current, say II, is the input current. Now, if we are able to find that this output voltage is directly proportional to the input current, then we call it a converter from current into the voltage, right? So 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 there is a circuit, there is a reference circuit that can be used for the conversion of input current into the output voltage. And the this current to voltage converter, it's an example of current controlled voltage source, because the input current controls the output voltage. So now let's go with the let's go with the circuit that's used for this kind of job. We have an operational amplifier, and it has an output, and it has two input terminals. One is inverting input terminal, another is non-inverting. Then we have a feedback resistance. Okay, so this is RF, and then we have the input signal. Now we have to have an input signal that's I, and then we have a ground here, and we have a ground here. So the point of contention here is that this is the standard circuit that can be taken as a basis to understand that how the output voltage is obtained by converting the input current. So this is the criteria that we want to derive from this circuit. So to move on, we can think of here voltage VB and VA. Let VA be the voltage at this point, and VB be the voltage at this point, right? So I think it's clear up to here. Okay, so we have a junction here. Let's call this junction as P. All right, and we can think of currents here. So suppose this is IF, and suppose this is IX, and here we have I1. Now, using KCL at junction P, that should be the case, right? So we can take the direction. I mean, because the current is coming from here, so let's take the direction in this way, and in this way. So in that case, I1 is IF plus IX, and this is understood that this IX is equal to 0. Now, if that's the case, then this this I1 must be equal to IF. Now let us see what is IF. That is VB to V0. So this is VB minus V out divide by RF. Okay, so this is my I1, and we can immediately think of this virtual ground. This VB is equal to VA, right? So this, if this is, so here we have the ground. So if this is zero, this is zero, then VB is also zero. So we can immediately think that using the concept of virtual ground, yeah, what we are going to get is VA equal to VB equal to zero. So in that case, we have I1 equal to minus V out by RF. Oh, so that should be clear from this. Okay, so this will be I1. Now, what is I1 here? I1 is clear. I mean, this I1 is the input current, and we can see that I is proportional to V out. Now, this negative sign is a consequence of using the input signal to the inverting terminal of the operational amplifier. That's why we have the negative sign in the final equation. So here we have come to a conclusion that the input current is directly proportional to the output voltage. So we can say that that we have obtained a relation for the input current and the output voltage. So this equation this equation represents that the output voltage is proportional to the input current, and certainly there is a role of feedback resistance, right? So with this, this is we have identified the fact that that using the circuit that I have drawn in the beginning, we can convert the current into the voltage. Okay, so if we take on this. If we take on this equation, we can have a little bit of modification here if we want, say for example, I1 by I sorry by V out. This is minus 1 by RF. So V out by II is minus RF. Now this RF, this V out by I in is called as trans resistance. So we call it trans resistance. And this trans resistance is simply equal to minus negative of RF. So we we can also interpret this this trans resistance gives us the measure of the gain. It's the gain of I to V converter.